Greetings everyone. I am Surya doing MTech CAD Camp in V8 University, Chennai. Today I am going to take a seminar on process steps involved in rapid prototyping. To start with, the intention of having a physical prototype is to realize the conceptualization of a design. The concept which we are having in mind, it can be directly seen as a physical prototype in this rapid prototyping or any type of prototyping. Prototyping process have gone through three phases of development. The first phase is manual prototyping, where the prototyping is being done in using hands, general simple tools which we use daily. And the second phase of prototyping is virtual prototyping, where the prototype is being generated in some CAD design softwares like CATIA, AutoCAD or something, and these CAD models are even analyzed in using other analyzing softwares like ANSYS. And it was not actually the model which we are going to produce. So the next phase of prototyping is where rapid prototyping comes. Rapid prototyping technologies are able to produce physical model in a layer by layer manner directly from the CAD models. So there is no need of any other tools or any fixtures to produce these rapid prototypes. Some of the examples of rapid prototypes can be seen in the images in the left side of your screen, where you can see miniatures of structures, buildings, and even a cycle stand, customized kind of stand, and the customized shoes can be produced using rapid prototyping. RP is capable to fabricate parts quickly with two complex shapes, easily as compared to traditional manufacturing technology. These RP are mainly used for producing customized parts and even prototypes of many other products which are going to be mass produced. RP helps in earlier detection and reduction of design errors even. By immediately getting a prototype in your hand, you can easily detect the error and even you can reduce the error in future, which is about to come in future. So how does this rapid prototyping work? We only need a printer, raw material and the software to tell the printer what to print. A virtual design can be produced in CAD model, and the CAD uses a 3D model, a scanner for virtual design. Here we are just seeing an CAD model of making a cup. First the CAD model is being done, then the model is converted to STL file format. It is then sliced into layers. These sliced layers are getting tool parts and it is being 3D printed and the object is finally obtained. So the process steps in additive manufacturing or rapid prototyping is that it can be categorized into three types. One is pre-processing, next the building of the part, and the third is post-processing. In pre-processing, CAD model is done using some CAD software and it is then converted into STL file format. In building, the model is sliced and the building of the object is done. In post-processing, you can see removal of supports and finishing of the product. So, to speak about modeling, 3D CAD model is a general prerequisite in RP process. Without this 3D CAD model, none of the RP process is possible. Usually, this modeling of this CAD model or the object which we want is the time consuming part of the entire process chain of rapid prototyping. Unlike numerical control programming, rapid prototyping requires a closed volume of the model. Because in numerical control, even an open model is enough to do the process. But rapid prototyping requires a closed model, which is generally represented in two types of formats like boundary representation or CSG. To the object is built using CAD softwares like OE or SolidWorks. AutoCAD is not used as it is an wireframe modeler. For better results, we generally use solid modelers. Considerations that have to be taken into account while doing a modeling is orientation of the part and need for support. Orientation of the part plays a major role in determining the staircase error. When the number of surface, when the area of surface of perpendicular is increased, the staircase error can be decreased. This staircase error can be decreased by even by reducing the height of each layer. And the next consideration in our model generation is support generation. Here, depending on the RP process used, we need to further define support structure for supporting the down phasing areas during part build up. Here you can see the hatched boundaries or the support structures of the required part. These support are very much helpful in holding our object, overhanging object in place, and it is also used to separate our object from the platform. And the next step in our RP is conversion of this file to .stl file format. Here the format represents a three-dimensional surface as an assembly of planar triangles. To establish consistency, the STL format has been adopted as the standard of rapid prototyping industries. Even IGES file format can be used, but to be very common with everyone, and most of the printing machines support this STL file format. So STL file format is used. Increasing the number of triangles improves the approximation. For a highly curved surface, many triangles will be generated, which in turn increases the size of the STL file format file. Generally, in most cases, this STL file size will be much larger than the actual CAD model itself. This is a kind of disadvantage in this STL file format. And the next step in our process is slicing of the object. It works on the principle that when it is possible to slice an object, it is also possible to glue them back to form a 3D model. Or rapid prototyping also follows this principle, where the given CAD model is sliced into each layer, varying from thickness of 0.01 mm to 0.7 mm, depending on the process technique which we are going to use for manufacturing of the object. This thickness may also vary within the object itself, depending on the size and the shape of the object or the cross section of the object. And the next path is for each layer, set of surface contours are obtained. Each layer doesn't have similar surface, and a tool path has to be defined within the material area for model production in a layer-based fashion. A tool path has to be generated for each and every layer of the surface of our object. Okay, the next part is the big part where the actual object itself is being built. To perform a print, the machine reads the design and lays down successive layers of liquid, powder or sheet material to build the model for a series of cross sections. Each layer is being built one on the above, and these layers corresponding to virtual cross section from the CAD model are joined together or automatically fused to create the final shape or can be automatically created. The advantage of this technique is its ability to create any shape or geometric feature. Uh, for most RP systems, this step is fully automated. Thus, intervention of humans is not required in this step. The building process may take up to several hours to build depending on the size and number of parts required. In the shown diagram, you can see this printer tooltip can move in all the axes to draw the required layer, and it in turn builds the product step by step. After completion of one layer in the process as shown in the diagram, the tool itself moves upwards so as to get a complete shape, or else there is even chances that the tool platform object platform can move downwards. The next step uh, in our rapid prototyping is post processing. This is the final step in rapid prototyping. This involves removing of prototype from the machine and detaching any supports. Most of the time, these supports will be soluble in water and it can be easily washed away. Or else, using some physical forces, we can remove the supports from the object itself, main object which we require. After removing of supports and other parts of the unwanted parts of the object, we have to cure it. Some photosensitive materials need to be fully cured before use. We can't directly use this object in the application which we want. It has to be cured to get the complete uh, grain structure of the object. Prototype may also require minor cleaning and surface treatment. Sanding, sealing, or painting the model will improve its appearance and durability. Durability and appearance can be improved by these methods. So this is how rapid prototyping was made from the beginning to the end. So you will see in a simple example how a rapid prototyping is being done. First, inkjet 3D, we will take an example of inkjet 3D printing. It creates the model one layer at a time by spreading a layer of powder as shown in the diagram, and inkjet printing binder binds the cross section of our required shape. Then the lower print bed moves downwards so as to get make space for the next layer, and again powder is being spread there and the binder is applied, and thus the finished product is being obtained. And the advantages of this inkjet 3D printing is unlike STL stereolithography. Inkjet 3D printing is optimized for speed, low cost, and ease of use. No toxic chemicals like those used in are required. Minimal post-printing finish work is needed. One needs only to use the printer itself to blow off surroundings. And the workflow of this 3D printing is first the CAD model is created using specialized software. Then it is being printed. Then in the post-processing, excess powder is being removed. Heating and curing is done for the object, and the polymer metal infiltration is being taken out. In this example, we will see a making of a 3D statue, a 3D statue of some toy or something. First, the object is being created in the CAD model itself. CAD model software like CATIA or SolidWorks. Then this CAD model is converted to STL file format and it is sent to a printer. Here the 3D printing is done as per the required dimensions. The binder is being applied to the surfaces wherever it is required. And the post-processing in this step is cleaning the 3D printouts, where the excess powder is removed by the application of a blower or something, air blow or water blow. And the minute powders, excess powders can be removed using brush by human normal intent application of brush. And the next step in this process is sintering, where the grain structures are formed together, and it is being sintered in an oven. It is heated below the melting point of the object so as to get a perfect sintering temperature. And the final finishing of the object is done by fine minute finishing by grinding or other things, and the painting is done. Painting and sketching is being done. Then the summary of this seminar is rapid prototyping technologies are able to produce physical model in a layer by layer manner. Process steps are first modeling. In modeling, orientation support generation are to be considered. Then conversion of the model to .stl file format. Then slicing of the model. Then toolpath generation. Then building of the model, and finally post processing, where we will remove the supports and do the finishing operations. And this is how a rapid prototyping is being done. Thank you.